All right, hello. So these are the lessons that were on September 17th and 18th, not 19th, September 17th and 18th about perpendicular bisectors. But let me show you where we started. I'm going to show this. I'm going to try to better align this to exactly what we're working on, because I know that we've missed a couple of these assessments and things like that, which I want to change to be helpful, beneficial. I want you to show me you know how to do this stuff, as opposed to it has to be done on this assignment. But I do have a few things that we can do here. All right, so we can go on our weekly learning. We're already on the next thing, but I have here the video for constructions, and now we're going to work on the perpendicular bisector. So you should have this come. This is in the student view, so you'll see this. So we can click on it. You will have to go through all of it. Standards are always listed here. We're still in the definition stage of perpendicular lines. Perpendicular, we will get into parallel shortly, angles, circles, line segments, etc. I know I read that out of order. I am sorry. We're also going to be making the constructions. Accessibility features are also here. All right, so the Johnson family. Basically what this is saying is that we have two families, well, same family, but two branches of the same family tree. One lives in Manhattan and one lives in Gaithersburg. And what they want to do is they want to meet each other somewhere in between. There's the wall behind us. Somewhere between the two, but they want it to be equidistant from both places, right? So it doesn't have to be in the middle necessarily. It doesn't have to be right here in, Philly. Although that does look like it's about the same distance from Gaithersburg as well as Manhattan, but that's only one option, right? We could, maybe pull out here. And then what we're asking in this page is to figure out and guess and notice some cities that may be the same distance from Manhattan as it is from Gaithersburg. So we wanted you to make some predictions here. It does look like, if this annotation tool wants to work appropriately now, from Gaithersburg to Atlantic City looks about that far away, and Manhattan to there looks about the same, could be the same, right? Let's see what else. Let's pick a different color here, maybe some purple. What's halfway? 1 second. Maybe Pottsville, right? Pottsville to Gaithersburg is there. Oh, maybe it's a little bit closer to Manhattan, but I need a way to test it, right? That's what geometry is about, being able to put forth something and then test it. All right, I'm just going to mute myself for a second. My daughter, she's playing, it's fine. All right, so those are different options there, right? So notice what other cities you have. Pause the video and guess. Welcome back. No, I'm just kidding. All right, let me clear this here, and we'll go on to the next one. Now, this one is a little bit off of my screen, and I don't know very well how to make it fit in my screen, but I want to show you how to figure this out. Where is that perpendicular bisector? All right. Well, we can connect Gaithersburg, and actually I want to do it as a line segment from Gaithersburg to Manhattan, right? Now, what is exactly in between those? Well, I'd want to bisect this line, right? And we just learned, or we will be learning, how to make the perpendicular bisector of this line. So how do you bisect it? Well, what I would normally do is I would make the circle and have one be the radius. There's a different way I can do it, maybe. This is what I like in geometry. You can be a little bit creative, and I know I'm a little bit off script here, but that's okay, right? How could I do that? I wonder if they have a compass tool, because every other time it's been exactly, okay. So I have to select, let me see, compass. So if I do that, Ah, it is that. Okay, so I'm going to make a segment out here because mine is a little too far, right? I can't get it on here, but I'm going to make just a random segment. This really doesn't mean anything. It's just going to be a tool. So here, if I use my compass tool, use this as my radius. Oh, I'd want it to be more than half. That is going to be a slight. Let's see if I do it again. I don't think these are going to cross. Nope, they're too far. So I need this line to be a little bigger. I wonder if I do that. Guys, we're practicing, we're playing. Just oh, it does. So if I extend that radius line, you can see that my circles are also extending, right? And you're like, oh, well, that's interesting. It is, because it'll set up that perpendicular bisector. What I have is I have a point here. I'm going to put a point. I have a point here where they intersect, as well as I have a point here where they intersect, right? As soon as I connect those two points, now I have my perpendicular bisector. So here I'm going to do a line this time, and I'm going to connect from E to F. And everything that is on that line, so I'm gonna can I hide these things here? We're still playing, I'm still learning, right? Oh, I can zoom out. That probably would have been helpful, but it doesn't matter. Anything that exists on this line here, let's see, any point that exists on that line here, any town that exists on that line there, is going to be the same distance from Manhattan as it is from Gaithersburg. So something like Ocean City, which is maybe over here, but maybe closer to F, that will be the same distance to Manhattan as it is to Gaithersburg. All of these, I wonder if I can zoom in. Can I zoom in? Nope, I did other things. That's okay. But show up. No, I went next. But that is how you can do a perpendicular bisector. Now, GeoGebra I'm not as familiar with. I'm going to get better throughout the year. That's the name of the game. We don't look for perfection. We look for progress. All right, so we did that. So now we are going to have some exploration of this using Desmos. So you can click on your own period there. If you have this period, just try it within there, and I'll see that you did the work, and I'll give you credit for it, right? Whether or not you can come to our class period. So I'm going to do it as a student. All right. So our learning objectives, and I do say the word so a lot, I'm sorry. Construct a perpendicular bisector and construct a line that's perpendicular to a given line through a point on that line. All right. So use the, see, I say it again. Now you're going to pay attention every time I say the word so. Use the line segment feature. Don't worry about the motorcycle outside. Or sketch tool to connect the points E and F. Next, you're asked to write a conjecture. And some of you may not have heard the word conjecture before. Here's a definition. A conjecture, by definition, is a reasonable guess that you are trying to prove or disprove, right? In geometry, everything is about proof. Everything has to be proven. You can't just say, it looks good, right? I say that a lot because, but geometry requires precision. All right, so I'm going to connect it. I'm going to use the line tool because I like things to be very straight. If you did not, that is okay. You do have to click and hold. I forgot for a minute. And if I connect it to F, there's the line. So now write a conjecture about the line segment you just created with line segment AB. Well, I've told you a couple things in that anything that's between E and F, any point on that line is going to be the same distance from A as it is from B. So I will show you, if it'll let me, this random point right here, from here to A, will be the same distance as here to B. All right, those two lines, if done properly, will be the same distance. All right, so I could say that any point on line segment, and I'll write segment, EF will be the same distance from, or to A, as it is, not to A, to A, as it is to point B. I should say point A and point B. I will put that in there just for precision purposes. Also, let me see, what other things will I notice? Well, maybe what I notice is that this E to here, the midpoint here, to B, that looks like a right angle, just like E to center to A, or A to center to F, F to center to B. All of them look like 90-degree angles. All center angles, or yeah, angles created by the intersection, and yeah, I'm going to be specific, right? The intersection of AB and EF are right angles. All right, there's another thing that I noticed. Or maybe I noticed that line segment AB is cut in half. All right, I'm going to pause this recording for just a second. It seems as if it's recording. I'll be right back. All right, so I just had someone come into the room, so I wanted to pause so that I could keep this up on YouTube. All right, so AB should be cut in half, right? This is the perpendicular bisector. Bisector, bi, the word bi means two, right? A bicycle, bicicleta, right, is two-wheeled, right? So two, bi means two. All right, so I would share that with the class, and you may do this at any point, right? We have some other answers in there. We won't see who they are, so you can really put in anything. Take that risk without the repercussion, without the consequence of other people seeing your work. I know that I'm more private, so I'll leave it like that. All right, so there is this video. We can watch it. It's 55 seconds. There's no sound. I will mute myself so you don't hear the sounds behind me. But what we're trying to do is I would ask you in class what you notice. All right, so what did we notice here? Well, in class, I would sit and pause and let you tell me these things, but some things that I've noticed, or maybe I should have talked through the video, but that's okay. They measured all of these angles here, right? So they used the Desmos tool to make those measurements, and when they did, they proved that these are all 90 degrees, all right? Any of these angles. Now you will come across, we will talk about lots of properties that have to do with this, and that is why we go through these constructions. It's not just, sure you have to do it, but that these constructions reveal properties that are always true, and that's what we'll have to use when we're trying to prove various things in geometry class. So I may say not bisecting line, the intersecting line, right? Because this didn't tell us line intersecting. That might be helpful if I spell things correctly, but that's what the red squiggly line's for. The intersecting line meets line AB at 90 degrees. I know there's a little button for degrees, but I'm just going to use that for right now. 90 degrees. I had another thought, and then I lost it when I thought about the degree. The intersecting line meets AB at 90 degrees, right? And we did that throughout the measurements, and that's fine for this one. More would be better, so please go in and say all those things that you notice. Here's another video. I'm going to say some of the things I noticed as we watch the video to save time. All right, so check this out. They have created a line on that line that they created. So they created a line on the line that they created. Not confusing at all. There is that perpendicular bisector already there. We know that it's there because it's labeled in yellow. As we move this point up and down this line, what we're noticing is the distance between that point and AB maintains, right? At this point, it was 2.98. If I go back a little further, 3.09, 3.09. If I move back a little further, oops, it's not on loop, that's okay. 3.88, 3.88, right? These are all what? Isosceles triangles that it's setting up. So that is something that we notice. Here we go. This video starts off by showing you that once the perpendicular bisector is created, the line segment is split into two congruent segment lengths, as you can see by the 3 tick marks on both sides. What those tick marks mean is that this from A to my center line, as well as my center line to B, are the same length because there's 3 on each. You can also see that where the white and black lines intersect, it shows you, it creates a 90-degree angle. That's what that box is right there. Anytime you see that box, you automatically know it's 90. In fact, it creates 4 90-degree angles, but only one is labeled. When making your conjecture earlier in the lesson, I'm sure many of us could see it bisected the line into 2 congruent parts, as well as made 4 90-degree angles, which we already discussed. However, there's also one more important thing we must remember about perpendicular bisectors. What do you notice about the point that slid up and down the white line? I may argue it's yellow, but that's neither here nor there. As we moved up and down that line, what we want you to notice is that it is exactly the same, right? It's an isosceles triangle. Those two sides, I know you can't really see it very well, but 3.88, 3.88, they're going to be the same. That is super important for you to understand. All right, let's create a perpendicular bisector of the line segment AB below, label the midpoint C, and again with line segment DE, label the midpoint S. You can rewind and watch this as many times as you want to until it makes sense, okay? It takes some practice, it takes some playing around with it, so don't be ashamed if you don't get it right away. All right, so what I'm going to use is a circle tool to start. If I click on the circle tool, it's going to make a circle starting at the center, and then it'll move. As I move out, you'll notice that that circle is going to get bigger. So here, I'm going to start at A, and I want my end point or my end of the line to be B. Why do I want that? Well, I just created a circle, a green circle, that has a radius of AB. Does it matter how long AB is? Not particularly in this moment. All I want to know is, can I create a circle that's exactly the same length? I can. Use B as your center this time and go out to A. All right. I know these two circles are exactly the same size because they have the same radius. All right. Let me just see. I'm just going to show you for fun if it wants to move. Nope, it doesn't want to move. If I place them on top of each other, they would be exactly the same. See, I'm still learning too. All right. The final step of this, well, to make the perpendicular bisector is connect where these two circles meet up top with where they meet down below. All right. The last thing it does tell me is label the midpoint C. All right. Well, what's the midpoint? Well, the midpoint is where these two lines cross. I'm going to label that by using my select tool, clicking on more tools, and nope, sorry, select tool, select it, and then you can label it. It automatically comes up with C. You really could put whatever point you want there. This tells us to label it C, so we do so. I want to prove to myself and you that I did it correctly. So I'm going to take my angle tool here. I'm going to connect my top point with C and B. You really could do any angle here because they will all be 90 degrees. And there we go. Actually, I'm not going to do that right now. I'm going to stop. Yeah, it's 180 degrees. Do I want to do that? No. Just going to do it again over here. All right. Why? Well, we have proven that it is perpendicular, but we need to prove that it's the bisector, meaning it cut into 2 equal pieces. All right, I am going to prove that by making a segment from A to C just for visual purposes, and if you can't see this, I'm sorry, I just want to show slightly, but it's just line segment AC, as well as I'm going to do another line segment from B to C. All right, I'm going to again just change the color so that maybe you can see that purple difference. And I can label it. And I can label it. And as you can see, it's 1.55 here, 1.55 here, so it is a midpoint. All right, we want to do it again. So let's do it again. Circle tool. D to E and E to D, right? This is dangerously close to being off the page. Not a problem. It is not there, so it's okay. I'm going to connect my points. So I'm going to connect the bottom, quote unquote, to the top. I'm just saying that as purposes of, but it's just where the two circles intersect connects those. And I'll just measure one angle here so you can see D to center. Oh, I didn't label my center, but I'm going to. There's 90 degrees. How can I label my center? Well, the point's there. So if I select it now, if I select this point, I can label it, right? And this one's just going to be F to be a new one. So those are at 90 degrees, and that's helpful. I don't need to check the other ones. We actually have a couple of properties here that we know make all of these 90 degrees. Since this is one line is 180 degrees. So if one part is 90, the other part is 90. I also could say, oh, well, if that's the case, then this is one line. So this is 90 and this is 90, etc. And I can keep going around. Another thing called vertical angles, which we will talk about. If two lines intersect, any angle over here is going to match the same angle over here. So these are all 90 degrees. And again, I just want to check bisector. So from D to F, as well as from F to E. I'm not going to change color at this moment, just so I can show you. You don't have to change color. But if I do that, and I select this one, and I label both are 2.91. All right. So they are perpendicular bisects. Sectors, perpendicular bisectors. Okay, next. We're going to slide point E along the perpendicular bisector. What do we notice about the distance from point E to point A and to point B? Well, as we slide it up, we've said this a couple of times. I hope that you can see it. And yes, do I want you to fill this out, even though it's sort of a repeat? Because I want you to see, I want to see what you're thinking here. And I want it in your own words. You may explain it in a way that's helpful for one of your classmates, or one of your classmates may write it helpful for you, right? We are in this together. We are a community of learning, and I want you guys to share with one another. But as you notice, as I move it up and down here, 9.47, 9.47. Even if it's really close here, 6.6, 6.6. If it's on the other side, still the same thing. We're always going to have the same distance. What do we notice about the distance from point E to point A and point B? The distance from point A to point E is always the same as from point B to point E. All right, something like that, but in your own words so I can see what it looks like. If you just copy my words, I'll know. All right, how to construct a perpendicular to a line through a point on a given line. So we're going to use the Desmos dynamic geometry tools to construct a line perpendicular to the line that goes through point C. Before we were focused on it to be, through, it was bisecting, right? So we had a whole line segment, which means it stops. This is on a line that could be anything, right? Could be any length. So here we want you to take a moment to think about what you've learned to this point about circles to see if you can construct a perpendicular line that goes through point C, right? So let me see what I can do. All right, oh, there's more tools here. Oh, here we go. Done. Yeah, so that's not the right way to do it, but it is a way to do it, right? It exists, so we're fine, right? That actually works, but we're going to do it in the next screen using, oops, they're going to show us how to do it on this next screen, right? So let's do it the right way because it'll display some properties for you. So what is it going to do? Oh, it's doing something with a circle tool. Okay, so it's going to make a circle here. Oh, I like that idea of keeping that point on that line. All right, so it's a circle with C as its center. Oh, and then, okay, put another point where that circle crosses that line. All right, so they labeled that A, and they labeled this B. Okay, that's fine. That looks, okay, I can do that. Next, oh, they're creating a line segment. Oh, they're doing it the whole circle, so the diameter of the circle, right? If it goes from one side to the other. I do it slightly differently sometimes, not a big deal. You can do it however. I will show you that in just a second. They're using this compass tool. In order to use the compass tool, you need to have a radii, right? Well, the radius for this circle is going to be the diameter of the circle. All right, I'm going to do it again. Use the compass, select the radius. It tells you how to use it there on the left. Select the radius and then move it to where you want it to be. And then, just like the other one, we connect the intersection of those two circles. Boom, done, 90 degrees. See, they're going to label your points. Always want to label your points just so we don't have to call it that point, that point, that point. And there we are. So I know that DE is perpendicular to AB. Awesome. All right, cool. So let's do it, right? Now, I'm going to show you, I do it slightly differently sometimes, right? I do the same first step, which is I just make a circle. I can make it as large or as small as I want to. I'm going to do it right there. I am going to label this point. And then what also they did is they did the other part where it intersects and just label it so I can call it something and not just say that point again because that is not descriptive. All right. So what I've shown, and let's just do it how they do in the video, but it doesn't have to be the diameter of the circle, and I want to show you that because that's how I showed this. You can do it that way. That works. I just have this other point here, slightly outside the circle, and I'm going to label it D. All right, and I created the line segment CD, right? I'm going to change that to an orange, just, oops, nope, it's just making points. Undo, don't worry, that undo button is there. So there's my line segment. I'm going to make it orange just so I can see it. All right, so this in the video they did as the diameter. Word just escaped me. They did it as a diameter. You don't have to, right? What we can do, but we do want it longer than the radius. We want our circle to be bigger than this circle. All right, so if I use my compass tool, it tells me to select or choose a segment to be the radius. It's going to be DC. All right, as soon as I do that, I'm going to center that on point B. Then I'm going to do it again. I'm going to click, and look, it's the exact same size circle. I'm going to do this one, though, on point A. Now, mine looks slightly different than it did in the video. That's fine. It's still the same thing. I'm going to, they you know, keep labeling points because points should all be labeled. I could put points everywhere if I wanted to, right? Because points exist. They have no shape or size. They're just very, very small. So here's my label. I am now just going to connect E to F. And there we are. It is A. E, C, A is a 90-degree angle, right? And if I want, I could hide some stuff, right? I could hide this circle. So that was the circle I put on. I could hide, not that when I want to do the circle, I'm going to hide it for a second and here, right? If I hide it, it's still there, right? I have 3 hidden objects, right? And they can come back. But that shows me that it is a perfect perpendicular line. All right, a couple more slides quickly. So here are the step-by-step directions. And I want to see, right, as soon as you get into the lesson, as soon as you start to play with it in the last slide, I want to see that. Now, if you need directions to what we did, again, they did it slightly differently. They did it as the diameter, but really it doesn't matter, okay? Do it your way, as long as it's 90 degrees. Not just that perpendicular line, though. I want you to see how to create it. But those tools exist, right? It's not a problem to have an understanding about what tools are in existence for you. But when we take progress checks, you're going to need how to do it with the circles. All right, and then finally, practice again, right? And I'm going to do it one more time, this time with the diameter, right? So again, point P, I'm just going to make a circle. Oops, I don't love that. I love having the circle right on the line, just so I don't have to worry too much about it. All right, so there's a point there. Here's a point on the other side. Let's label them. This is point A, and this will be point B. Then I'm going to make the diameter, which is from A to B. And I'm going to color it a different color so that we can see that. Orange sticks out the best, but you're not missing like too much. I'm just trying to show you the difference if you cannot see that. All right, then I will use my more tools. I will use my compass tool. My diameter is now my radius of my big circle. And do it again. My diameter is now my radius of my big circle, and the center is going to be, one center will be on A, the other center will be on B. As soon as you do that, a slightly extra step, but a good one nonetheless, and connect those lines. And there we go. That might be neater for you because it goes directly onto the sides of the circle, because the diameter of the small circle is the radius of the large circle. But it doesn't have to. It just gets a little messier. Oh yeah, let me show the 3 hidden objects, right? Like this one, it doesn't matter that it's a different shape. Oh, or not different shape. It is the same shape, but it's different, like it's not exactly to the sides. I don't know. I like how it looks. You gotta find love, can't find joy. Find joy in math. All right. So that's how you create the perpendicular bisector, through the given point in the line. All right. There's practice on this. Please try it. It's actually, we had to practice again on Monday, the same skills here. So if you can do this, then you're good for Thursday and Friday, as well as Monday, because Monday is another Desmos activity that really is just me seeing that you know how to do these things. All right. We will be moving to parallel lines shortly. Any questions, please make sure that you email me, message me, ask me, and I'm happy to help. All right. Have a good one.